Hello and welcome to Algebra 1, Chapter 10.4, and today we're discussing the Pythagorean Theorem. So first of all, we need to discuss right triangles because the Pythagorean Theorem only works for right triangles. And so here we have a right triangle. It will have a right angle in it, and typically you would see a box in a corner like that representing a right angle. The hypotenuse is the side opposite the right angle, so this side over here is the hypotenuse. And it is always the longest leg. And you'll discuss that a little more in geometry. But since your right angle in a right triangle is the largest angle, the side opposite it is the longest side, and that's the hypotenuse. The other two sides are just called the legs of the triangle, and they then form that right angle. So Pythagorean theorem says that the square of the length of the hypotenuse, so if the hypotenuse is c, the square of that length is equal to the sum of the squares of the legs. And so if the legs are a and b, then we have the sum of the square of the legs. Lots of people flip it around. A squared plus b squared equals c squared. That's how I will refer to it. So to use the Pythagorean theorem, you have to know you're dealing with a right triangle. So find the length of the hypotenuse of a right triangle. So that's important. And so really what you have is you have a formula and you have a missing piece. And so this specifically tells us that A is 18, that B is 24, and so you plug those in, and the whole question then is what's C? Well, let's go ahead and actually square 18. 18 squared, 324, plus 24 squared is 576. And then if we simplify that, it actually adds to be 900. And that equals C squared. But C is the length of the hypotenuse, so to just get C, we're going to square root both sides, and the square root of 900 is 30. Okay, so we don't always have to find C, you could find another side. So in this case, we have B as the missing side. So I'm going to go ahead though and write out my Pythagorean theorem, and I have a right triangle. So that indicates I have a right triangle, so I'm good here. So let's make A is 9, because A has to be a leg, and B is going to be B, and C is going to be 16, because that's the hypotenuse. So the goal is to solve for B, so let's do a little bit of simplifying here. This is 81 plus B squared equals 256, and we got to get B squared by itself. So if we subtract 81, B squared equals 175. And we're going to go ahead then to get rid of the squared, we want to square root it. And so we have the square root of 175. Well, we're going to try to simplify this. So what squared number goes into 175? It's 25, so 25 times 7, so this becomes 5 square root of 7. One thing that's nice to know about is called a Pythagorean triple. And a Pythagorean triple is any three numbers that satisfy the Pythagorean theorem and any multiple of those three numbers. So for instance, I know that 3, 4, 5 works in the Pythagorean theorem. So, because if I had sides of 3 and 4, and I solved for the hypotenuse, this is 9 plus 16, which is 25, and when I square root, I get C equals 5. So I know 3, 4, 5 works in a right triangle. So then I know 6, 8, 10 works in a right triangle. Or I know 9, 12, 15. Okay, these are Pythagorean triples because I took this one that I know, and this one then is times 2, or this one is times 3. So any multiple of this is also going to work. So if I wanted to take it times 10, 30, 40, 50 would work. That's what a Pythagorean triple is. All right. Question here is, what's the area of this triangle, triangle XYZ? Well, we've talked enough about area of a triangle to know it's 1/2 base times height. And I'm going to say 28 is my base, but what's my height? So this is where Pythagorean theorem might come in. If we solve for our height, then we can use that to find our area. Now I want to bring up something real quick. I know that you could take the Pythagorean theorem, right? And you would solve probably for B, because that side would be B, and you would go on with your area. But let's talk about what we just did about Pythagorean triples. And remember that I said 3, 4, 5 is a Pythagorean triple. And looking at my hypotenuse here, it's a multiple of 5. It's 5 times 7. So is 28 something times 7? It's 4 times 7. Okay, so do you see where I'm going here? I have 4, I have 5. This other side must be 3 times 7. So 3 times 7 is 21. So this is a Pythagorean triple on that 3, 4, 5. They're all times 7. So then there is already my height. And if that didn't make sense, or if you didn't think about that, stick right with your Pythagorean theorem and just solve for it. There's nothing wrong with that. So this is 1/2 times 28 times 21. Plug all that in your calculator. You get 294, and since it's area, we're going to say units squared, since we do not know what we are measuring in there. All right. Word problem here, and I have to bring up that Pythagorean theorem is probably one of the most used math equations, just because it really assures you that you have something that has right angles. And so if you're building something, or if you're even laying a driveway or walkway, and you want to assure that you have right angles, all you have to do is work out the Pythagorean theorem and check your results. So here we have a square shopping center has a diagonal walkway from one corner to the other. So square shopping center, so I bet that's important. Square shopping center, diagonal walkway. So if it's square, that means I have right angles. If the walkway is about 70 meters long, so I know that's about 70, what's the approximate length of each side of the center? So the question is, what's this? And I know they happen to be the same thing. Well, if we put this into our Pythagorean theorem, so let me write it out again. So let's say we have x squared plus x squared, because they're the same thing, equals 70 squared. Well, x squared and x squared are like terms. So if I have 1x squared plus 1x squared, I actually get 2x squared. And 70 squared is 4,900. Divide by 2, because you want your x squared by itself. So then x squared is 2,450. And then how do I get rid of the squared? I'm going to square root it. So then x equals, and we're just going to go into a decimal. And that was in meters. So the last thing we want to talk about is the converse of the Pythagorean theorem. And converse just means to kind of go backwards. So the Pythagorean theorem said if you have a right triangle, then a squared plus b squared equals c squared works. The converse says if a squared plus b squared equals c squared works, then we have a right triangle. So this is actually a test for a right triangle. So how the converse works is, if you have these three sides, so let's say 7, 12, and 15, do they belong to a right triangle? Well, they're going to belong to a right triangle if it works in the Pythagorean theorem. And so all you need to remember is that the longest side has to be C, and it doesn't matter what the other two sides are. So let's just say we have 7 squared plus 12 squared equals 15 squared, and you're working straight down, don't move anything over to the other side. Essentially, it's a check is what you're doing. So you're going to have 49 plus 144 equals 225. So all I did was square everything. And now if I combine the numbers on the left, I get 193 equals 225. So no, that one's not a right triangle. So let's look at the other one. We're going to have 27 squared plus 36 squared equals 45 squared. So plug in your numbers, do the math. 729 plus 1296 equals 2025. Add the numbers on the left-hand side. 2025 equals 2025. So yes, that is a right triangle. That's how the converse works. All right, that's what I have for you for 10-4. Let me know if you have any questions. If not, I will see you in class next time. Have a great day.